Welcome to JCON! Thanks for a great introduction. Hello everybody. It's my pleasure to take this keynote here. It's awesome. Richard told me, Markus, you have to cover the keynote. It's because of nobody pays more than you. And this keynote is different, so it's not only about myself or my projects. I do the keynote together with Ariane from Oracle. And thank you. And first of all, I like to thank Richard, because he has forgotten to thank himself. And it's because of, I think he does a great job, and did a great job, of course, the last years. But I had to force him. Because when we started JCON, before he said, we cannot run a Java conference, impossible. So because we run a smaller conference before, and then we had an idea to run a Java conference. And now he's the main organizer, and so did a great job. Thanks, Richard. All right. I'd like to thank also the amazing speakers, and we had a lot of proposals for a CFP, and then we had an idea, so we cannot accept all talks, of course, otherwise we had to book next time some more space in the cinema, but we produced a new magazine. So JAVAPRO started when JCON started as a printed Java magazine, the first or the only free magazine, printed magazine in the world for Java developers. So we were able to order the magazine for free of charge. Through COVID, we were forced to continue with the online magazine, but this year is special, 30 years of Java, so we printed a special edition, 30 years of Java. And hopefully we will be able to introduce the magazine through the conference, so it was very close. And a lot of speakers submitted for an article, so thank you for that. And if you're an author or a speaker, you can use JAVAPRO for writing articles about your technology, what you're working on, what you're speaking about, and promote yourself and share your experience with the Java community. That's awesome. Thank you. All right. And now this keynote is really different. So it's all about improving the speed of databases by using open source and pure Java. And who thinks that have already heard about what I'm talking about, I can tell you it will be different because we have a lot of things to announce today. So my name is Markus Kett. I work for MicroStream and support the JCON conference and the Java magazine. But mainly we work on open source projects. So we work on the Eclipse. So we have worked on the Eclipse tools for 10 years, built an IDE, a kind of visual Java IDE for Eclipse and for Java, and worked on improving the JBoss Hibernate tools. And so for a long time, tried to improve it, make it Hibernate development more convenient and through runtime faster. Then we started an open source project called Eclipse Store and started a second Eclipse project called Eclipse Serializer, and this is what we have been working for almost 10 years or even longer. So we're a member of the Eclipse Foundation. We're integrated with Micronaut. We're also well integrated with a project Helidon, which is also a microservice framework. And so Eclipse Store is growing, it gets more and more popular. But what's the story and the goal behind? So we worked on the JBoss Hibernate tools for a long time, and we saw that our users had often performance issues with Hibernate and was very complicated, and yeah, so not so really convenient. So the basic question was actually, what's the core problem? And so there are a lot of solutions on the market, but all databases in the Java object model are incompatible. And I think this is the main problem. So we have objects in Java, and you can deal with any Java types. You can build your object model freely, but you can't store it in a database. You cannot store it as it is in memory. So this is a big problem and leads to further complexity, and actually to insane complexity and to insane results. With the new NoSQL databases is similar, because they introduce new data structure or data types, but they are also incompatible with the native Java object model. So you have convert the data through runtime. It leads also to more complexity, to more overhead, and to performance losses. Of course, the problem is basically solved if we use object relational mapping, and because of object relational mapping is time consuming through runtime, we need a cache, so we add a cache. That's also solved, but still it's very slow when we use Hibernate through runtime, mostly. So who of you has performance issues with JPA Hibernate? Okay. All the others work with Eclipse Store already, I guess. Thank you. So when it gets more complex with distributed applications, then we have to change the cache strategy. All of this is very common. Then, of course, we can use a distributed cache. So put the cache between the application and the database to accelerate database queries. And if you have more load on a database, of course, then we use a database cluster. That's common. Here we can see a distributed monolith, and this should be a microservice architecture where we have multiple services that scale independently, horizontally. Gets more complex, and mostly when we use a distributed cache, then we have the requirements. It would be great if we could search and filter on the in-memory data. And this is the reason why the searching servers became popular, and a lot of users use Elasticsearch, for instance. So more and more layers, and it's just for processing data. And with microservices and multiple domains to deal with, then we often have the situation where we need multiple different database types. So maybe a relational database, a graph database for data analytics, or whatever, document database, and now the vector database. And so multiple databases to run, to maintain, and data to convert from database-specific data structure to, again, Java objects. So, and this is the reason maybe why cloud costs are skyrocketing. So it's a great answer for managers. So, and we were like, can we improve it or make it more simple? And it's because of we have a powerful programming language, and a lot of developers told me years ago we had already idea, just use serialization, do everything with Java, use the power of the programming language, and build an in-memory application like banks do it, or online gaming companies. So this functional principle is very common, but they all have to build their own in-memory database. And mostly they told me, yeah, but we stopped doing that because when we serialize objects, to disk, then there are so many challenges, further challenges, so we stopped doing that because, yeah, if the schema changes, what about scaling and so on? There are a lot of drawbacks. And so we were trying to solve all of these problems and started working on this 10 years ago. And I would say we have solved 99% of all of these problems, and I'd like to introduce you to the result, to the end result. So Java in-memory data processing, like the banks do it with the high-frequency trading applications, the trust on the performance of the programming language because they need microsecond response time. When we talk about the performance of a database, we talk about milliseconds, and with pure Java, we talk about microseconds. We have a multi-model data structure already. We have the object graph model. You can use any data type, you can use any Java type, you can do everything. You can design it freely, you don't have to care for a database structure. And you have a query language, you have Streams API. I have to go through a bit faster. Also you can navigate through an object graph very easily, just with calling a method. And it's more convenient and simple than using a query language or learning a new query language, like all the database vendors have to provide a query language. So imagine you do everything with Java, you can use everything that the language provides you. You can use any Java library and combine it and build a powerful in-memory database application. The only thing missing in Java is persistence, because the relational database is successful and is dominating the market for decades. It was obvious, of course, to use a database. With Eclipse Store, we created a persistence framework that can replace Hibernate. It stores your objects as they are persistently on disk. And to make this possible, we had to create a new serialization framework because Java serialization was not able to do that. So we developed the Eclipse serializer, which is the core of the Eclipse Store project. So with Eclipse Store, you can store any kind of object graph, any complexity, any size. You can use any Java types, collections, whatever. So, and you can store it and restore it in memory when needed. So this is, I don't want to go too deep in this project. You can check this out. It's an Eclipse project, open source under EPL license. It runs wherever a JVM is available, with all JVM languages, of course. The only requirement is Java version 11 or newer, of course. There's also implementation for Android. Runs in the cloud, runs with Java native, with GraalVM native images. And you can store the data, which is stored in a binary format. So the Eclipse serializer uses a binary format to store the data persistently on disk. Of course, it's also open format and it's under EPL license. And you can store it wherever you can store binaries. So in a cloud object store, like S3, for instance, directly on disk, or even in a database, because databases can store binaries. So we also provide lazy loading, so you can also deal with small memory sizes and have a big database size. This also works really great, and it's battle-proven. So it's used in production by companies like Allianz for many years. So the problem was that so far, it was built for monolithic applications because we started 10 years ago. Monoliths were common. Then the cloud came up and distributed applications and microservices, of course, and so the requirements were, Eclipse Store is great, but we can't build distributed applications. So we tried to convince the community that you don't need a microservice infrastructure for every purpose. So a monolith is great. It's extremely fast and mostly, or in any case, easier to develop, to maintain, and so on. But community told us, no, we need horizontally scaling in any case. So, okay, we started to work on a cluster solution. So we worked on Eclipse Store Cluster, and some month ago, we introduced Eclipse Store Cluster. It's based on a Kubernetes environment, so you need Kubernetes. This is the only requirement, and then you can deploy your jar very easily. You have a graphical user interface, and you can configure how many nodes you want to run and how it should scale elastic. So horizontally scaling out, scaling in, you can configure everything. Super easy to use. There was just one drawback, was commercial solution. And the Java community of course, loves open source. And so we wanted to be the good guys, of course, and wanted to make you happy. And so this is the reason why we now decided to open source the whole stack. And this is my announcement today, or the announcement of the whole team, that we open source the whole cluster infrastructure as an Eclipse project. I didn't talk to Eva to check this stuff here. So this name is just a project name. Hopefully it will be accepted. Then we call it Eclipse Data Grid. Here is the whole stack. Then you have the Eclipse serialization framework. It can deal with complex object graphs, circular references, any Java types. It's very fast and very secure, so no deserialization attacks possible. Eclipse Store as a storage framework, and it's, by the way, ACID compliant storage. And on top of that, the Eclipse Data Grid with all the Java core features. So it's not our invention, of course. This is just core Java stuff, Java Streams API, and the object model of Java. And this is, by the way, the main difference to other data grids on the market. So this is the only solution that uses the native Java object model. So then we added in an indexing framework and a project called GigaMap, which is enables fully automated lazy loading. So this is super convenient. It feels like you work on a big table, but it's a Java collection, Java map, and fully indexed support. With this indexing, you can search billions of objects in milliseconds. So this is a brilliant solution. It's production ready, and it only depends on how fast we can launch the Eclipse project. So if you need this urgently, go to the Eclipse booth, talk to Eva, and you say, yeah, we need it urgently. So this is what we have been working on for more than 10 years. And this was our dream to contribute to the Java community and build something that is has impact and is important for the community. Thank you. Thank you. There is already a fully managed service, and it's because we run it under the roof of MicroStream, because the Eclipse Foundation is a non-profit organization, so we cannot run a SaaS solution where we have to charge, and we have to charge because we have to charge for the infrastructure. And under the roof of MicroStream, we will provide this Eclipse Data Grid as a service for free of charge. We only charge you for the infrastructure costs and nothing else. And we provide enterprise support for the open source stuff, of course. And of course, other vendors can take it. It's under EPL, which means for commercial purpose, for building closed source application, you can use it, fork it, build your own products, and if you like, contribute to the project. So here is the overview about the architecture. Then you can run it with microservices, with distributed monoliths, with a monolith. You can use, of course, you can still use your primary database, or just use only one primary database and use it as an in-memory caching layer or in-memory data processing layer, then you benefit from both the power of Java, core Java stuff, microsecond response and query time, but you also benefit from your database and save a lot of database costs because the load is on the Eclipse data grid. That's the whole stack, and also the JVM matters. So we have a lot of different JVMs in the Java ecosystem. Check them out, they are different. OpenJ9, for instance, is also an Eclipse project, but there are many different vendors, and the latest Java versions are the fastest. So migrate always to the latest Java version, makes sense. Sometimes there are 20 or more than 20% faster, which means you build a business application, and then you can tell your customer, so we made a lot of improvements to make your application 20% faster. We charge you a lot of money, that's clear, but actually you just migrated to a latest Java version. That's great. And this complete stack will also run in the Oracle Cloud. So this is the next new announcement. We will run this in the Oracle Cloud, Eclipse Data Grid as a complete Java in-memory data stack in the Oracle Cloud. And why this is so great, this will introduce Ariane from the Oracle Cloud team. The only thing I want to add is, if you like the stuff, you don't have to pay us, but please star us on GitHub. This is the currency for open source. Fork it, contribute if you like, and give us feedback. We are keen on getting your feedback. Stop at the Eclipse booth and have a great JCON. This is the most important thing. Enjoy the great sessions with the great speakers and have fun for 3 days. Thank you.
So I'm the secret guest speaker today. I'm that secret that even Richard didn't know about me until 2 hours ago. But as you can see, I could convince him to get me the nice speaker t-shirt, which are really comfortable, and you should definitely get one yourself as well. So good job for that. My name is Ariane Müller. I'm working for Oracle. I guess you might have heard the name before. Usually when I meet people for the first time that also work in IT, I ask the question, so when you hear Oracle, what comes first to your mind? And usually I hear either databases or Java. So I think here I can spare the question. The answer is pretty clear. So what most people don't know about Oracle is that we also entered pretty successfully the cloud market a few years ago. I see a few people are nodding. Thank you, I appreciate that. And even that successfully, that companies like OpenAI and also Microsoft decided to run their AI deployments on our cloud. You heard correctly, Microsoft also decided to run their AI deployments on an Oracle cloud. Now, what do you think why? Question to you guys. Two reasons are there. Why might Microsoft have decided that? Okay. There are a few good ideas, so I help you a little bit. First is cost. The world is driven by money, right? So the first thing was cost. And that might sound a little bit strange to you. How can it be that it is cheaper to run this stuff on an Oracle cloud? So there's a reason for that. And this is also the second reason, which is performance. So if I manage to send you away from this session with only these two things, it is cheaper and runs on bigger performance in an Oracle cloud, then I did my job, I think. So let's see if I can slip here to the next slide. So how can it be that it's cheaper and more performant? You will see. So let's say only until now we are like around 10:30 or something, 10:30 a.m. If you, just an assumption, would have been starting your day, maybe you woke up in the Marriott here in Köln, then you have been sipping your coffee, your Starbucks coffee. Then you have been waiting maybe for your Uber to come here to the hotel, or maybe walking 1 kilometer is also fine when the sun is shining. and you paid your Uber with your Deutsche Bank credit card. So only until this moment, you would have been using already 5 services that are powered on OCI. And you didn't even know about it. And there are so many more. In roughly, let's say, 50 years on the market, we did a few more things than Java and databases. And so what was the idea behind it? Let's say Larry Ellison had an idea. He did not only want to enter the cloud market, he said, I want to be the first. I want to be the best. So if you want to be completely disruptive and you want things to change, you cannot just copy the others, right? So what did he do? He went to Microsoft, he went to AWS, and he got the best engineers and probably paid them way too much money and asked them a good question. If you could start the game completely from zero, if you could design a new generation cloud, how would you do that? And they came up with very smart things that I cannot repeat here even. I know a few very smart people that could explain it in a good way to you. And if you request afterwards a one-on-one meeting with me, not through the app because I'm the secret speaker, yeah, I'm not even in the JCON app, but you can do it old school and tap on my shoulder, and then we can go for coffee. So if you would ask, what did he do? He designed the cloud completely different. So we have here an optimized hardware. We have bare metal instances for compute-intense Java applications, also for other applications, but let's focus on the Java applications here. And you will feel, if you run the very same application on, let's say, another hyperscaler and on Oracle Cloud, you will feel the performance increase. We have here ultra low latency, and I can back that up with numbers. Not right now, but if you tap on my shoulder, I might be able to. The second, so in the end, you will feel extremely fast application response times. And this is not just marketing BS, this is really true, and you can test it out, and I invite you to do that. What we have here, you can easily scale your Java applications if you have varying workloads. So OCI also supports autoscaling, so that you can ensure your application remains responsive, also when you have peak times. And obviously, also we have integrated advanced security features, for sure. Who of you know the Oracle Cloud Shell here? 2 hands are going up. Well, if you leave the room today, I hope a few more hands getting up. So what is the Oracle Cloud Shell? It's a web browser-based terminal that is accessible from the Oracle Cloud Console. So basically, it's an environment with pre-installed Java tools. And for seamless integration, you will have there also the popular Java IDEs. Here we go. So, Markus gave me only a few minutes here, so I'm going to be very quick. We will have also the possibility to use Docker and Kubernetes, so you can containerize and orchestrate easily your Java applications here. Then you will see also we support the key tech integration, what you see here on the slide. And obviously, we have also integration with popular tools like GitHub, like Maven. And that brings me already to this slide. If you say, okay, good. This all sounds very good, but we are here in Germany, and the German people like to have everything in Germany. And well, a cloud there back in the US, not really sure about that. We have also the solution for that one. So Oracle Cloud comes in probably 10 different flavors. I bring you only one here today. It is called the EU Sovereign Cloud. So this is a cloud which is run 100% by EU citizens. They are not contracted under an Oracle Inc. There is a separate, complete, independent company that is running all of those things, and the data will stay within Europe, within Germany, that the Germans are also made happy. So this is the good news. Thank you. I will give the feedback to my manager to say we love the EU Sovereign Cloud. So, is somebody from you here playing the guitar? Nice, a few hands. I'm also playing, I have to say, not as good as I would play here on stage, but still a few things I can, a few chords I can strum as well. So just to give you one example, we had this project with a company called Guitar Center, and they had a few problems when it came to scalability. So they were completely on-premise, and there was a shortage on chips. They were not anymore able to scale in the way that they wanted to. So what they did was, in the end, they took their whole environment, they migrated it to an Oracle Cloud, what a surprise, And in the end, they saw that a 30% performance increase happened. And I'm not speaking here just about, like this is, sometimes around 30. Usually we see a significant increase. And this significant performance increase leads to significant cost savings. What we see usually, and that's why I said at the very end of my very short presentation, we see usually around 30 to 50% cost savings, especially when it comes to compute and storage. Some customers even save up to 90%, but those big numbers I don't like throw out in the very first contact with a customer. Usually I say 30 to 50%. And all of this cost is freed up and can be invested in other things, right? Like very nice new projects, for example. And this company, Guitar Center, experienced exactly this. So they saved 1.5 million in the very first year, and they're expecting more than 40 million of savings over the next 3 years. And this money can be invested in your new projects. Sounds good? Does it sound good to you? Good, happy, cost savings are also good. So that brings me to the very last slide. As I said, I'm the secret speaker. You won't find me in the application, but I'm on LinkedIn. So if you don't find me for one-on-one, feel free also to reach out to me over LinkedIn, for example. Very happy to be in touch with you and answer your questions. Thank you, Markus, for the secret slot.